recording. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to review for the Chapter 11 test coming up tomorrow. And I've got a bunch of questions people sent in, and we're going to get to those. But before we do, I just want to quickly review formulas that you should know for this upcoming test. All right. First of all, changing an exponential equation to a logarithmic equation, or back and forth the other way. So let's say you've got y equals b to the x. Okay. That's an exponential equation. And then writing it as a logarithmic equation, it would be log base b of y equals x. So the base stays the same, but the other two quantities change places. And this is a two-way statement. Starting here, you can go there. Starting here, you can go there. All right. Also, we've got, let's see, the compound interest formula. A equals P times 1 plus R over K to the KT power, where P is the initial investment, R is the annual rate, T is time in years, and K is the number of compoundings per year. If we have a situation where it's compounded continuously, then we have this formula where P is the starting amount, R is the annual rate, and T is time. Let's see, we have the change of base formula. If we have log base b of x, that's equal to log base a of x divided by log base a of b. We have the doubling formula. The natural log of 2 over r equals t. And we have the half-life formula. Let's see, a equals a sub 0 or a naught, and then it's 2 raised to the negative t over h power, where a sub 0 or a naught is the starting amount, a is the ending amount, t is the time, and h is the half-life. Anyway, so these are formulas that you should find coming in handy on this upcoming test. All right, that takes us to our first question from WebAssign. And so let's take a look there. This is section 11.7, problem number 10. It says, in 3 years, 30% of a radioactive element decays. Find its half-life. Okay, so let's go back here. We're going to use the half-life formula. A equals a naught 2 to the negative t over h power. It says in 3 years, 30% of a radioactive element decays. Find its half-life. All right, so the time would be 3 years. The half-life, h, is the unknown that we're trying to find. It says 30% of a radioactive element decays. So we don't know the starting amount. That's just going to be a sub 0 or a naught. The ending amount, if 30% decays, the ending amount is 70% of the beginning amount, okay? 30% goes away, so 70% is left. So the A is 70% or 0.70 or 0.7 times a sub 0. Okay, any questions on that? All right, now plugging in the numbers and quantities, we get 0.7 a sub 0 equals a sub 0 times 2 to the negative 3 over h power. Dividing both sides by a sub 0, 0.7 equals 2 to the negative 3 over h power. Taking this exponential equation and changing it to a logarithmic equation, we get log base 2 of 0.7 equals -3 divided by h. All right, so I need to get h by itself, and it is in the denominator. So I'm going to multiply both sides of the equation by h. On the left side, I get h log base 2 of 0.7. On the right side, I get -3. Now I'm going to divide both sides by log base 2 of 0.7. Log base 2 of 0.7. So h equals -3 divided by the log base 2 of 0.7. But using the change of base formula, that would be -3 divided by log, I'm going to use base 10 of 0.7 divided by log base 10 of 2. And I'm going to group that denominator. So in my calculator, I'm going to put in -3 divided by parentheses log of 0.7. I'm going to close up the parentheses around the 0.7, then divided by the log of 2, close that up, and then close up the entire thing. So let me see here. Where have I got parentheses? I've got parentheses here and here and here. Okay. My answer is coming out to be 5.83, et cetera, et cetera. And it said round your answer to one decimal place, so 5.8 years. Are there any questions about how I put things in the calculator? Anything else there before we go on? All righty. Next, we're going to do problem number 12. And let's see here. So this is 11.7, number 12. And let's take a look at that on WebAssign. And okay. An isotope of lead, 201 PB, has a half-life of 8.4 hours. How many hours ago was there 80% more of the substance? Okay. So we're using the half-life formula. A equals A sub 0, 2 to the negative T over H. And we know that the half-life H is 8.4 hours. How many hours ago? So time is the unknown. But this one is a little bit different because it's going into the past. So it says, how many hours ago was there 80% more of the substance? Okay. So the final amount is A, but A sub 0 would be, and let's see here. Where did my mouse go? There it is. Okay. So how many hours ago, we're going into the past, was there 80% more of the substance? So this would be 80% more than this. So A sub 0 would be 1.8 A. Does that make sense? It's a little bit tricky there. Questions how I got that? Okay. So now, instead of replacing A with some amount of A sub 0, we're going to replace A sub 0 with some amount of A. So our equation is going to be A equals 1.8 A 2 to the negative T over 8.4 power. Okay. We're going to divide both sides by A. So on the left side, we don't get 0, we get 1 equals 1.8 times 2 to the negative T over 8.4 power. Okay. Going to divide both sides by 1.8. Let's see, I'm going to change 1 divided by 1.8. That would be what? 10 over 18 or 5/9 equals 2 to the negative T over 8.4 power. Are you okay how I got from here to here to here? Any questions there? All right. So then I'm going to get
I was a little confused how you got to or 10/18.
Okay.
Me too.
Okay. So if you've got 1 over 1.8 and you multiply by 10 over 10, you get 10 over 18, clearing the decimal in the denominator.
Okay.
Okay,
In other
yeah,
words,
I see.
you move the decimal to the right, right?
Yeah, one place. And then just reducing that down, cutting it in half, you get 5/9. You know, and I could have left it as 1 over 1.8. I just kind of wanted to clean up the fraction. All right. So now I've got can somebody mute their mic? We're hearing some stuff in the background there. Okay, thank you. So now I've got that equation that I just circled. I'm going to change that to a logarithmic equation. So I'm going to get, tell you what, let's take that and go to the next page. So 5/9 equals 2 to the negative t over 8.4 power. So that becomes log base 2 of 5/9 equals negative t over 8.4. Okay. To solve for t, I'm going to multiply both sides by negative 8.4. So on the left, I get negative 8.4 log base 2 of 5/9. On the right, I get t because the 8.4s go away and the negative times negative is positive. So t equals negative 8.4. I'm going to use change of base. So I'm going to get log of 5/9 over log of 2. Going to the calculator, I get negative 8.4 log of 5/9, close that up, divided by log of 2, close that up, and I come up with 7.123, etc. It said round to one decimal place, so it would be 7.1 hours. We okay with that? Alrighty, we're going to go.
Yeah, you explained that pretty well. Thank you.
Okay, we're going to go on to another person's questions. So let's see here. Give me a minute. And there. And here. 11.7. Okay. Now, I'm a little baffled. This student asked me to do problems 11 and 12 in 11.7, but I noticed they hadn't done problem 10 and they did 11 correctly. So I'm wondering if maybe they wrote down the wrong ones. So I'm going to start with problem number 10. And let me get that up on the screen. So this is 11.7 number 10. Okay. It says in 4 years, 30% of a radioactive element decays. Find its half-life. Okay, so A equals A naught 2 to the negative T over H power. Time is 4 years. Find the half-life, so H, the half-life is the unknown. Now, 30% decays. So we're starting off with A sub 0. We don't know what it is, so it's still going to be A sub 0. But A, if 30% decays, 70% is left. So the ending A is 70% of the beginning A sub 0. You okay with that? You got to read those carefully because they'll switch them up on you. Sometimes it'll tell you what's left. Sometimes it'll tell you what decayed or what went away. All right. So now I've got 0.7 A sub 0 equals A sub 0 times 2 to the negative 4 over H power. I'm going to divide both sides by A sub 0. So 0.7 equals 2 to the negative 4 over H power. So we get log base 2 of 0.7 equals -4 over h. And I'm trying to get h by itself. I'm going to multiply both sides by h. So I get, yes.
Excuse me.
Yes.
I don't think we can see the screen.
Oh, I didn't switch back. Sorry. Yeah. Tell me sooner, guys. I'm off in La La Land here. Sorry about that. Okay. Okay. So, yes, thank you. So we've got this starting amount, okay, our formula. So we get 0.7 a sub 0 equals a sub 0 times 2 to the -4 divided by h power. You okay with that? We okay with that? Yeah. Okay. Yeah. Divide both sides by a sub 0. So then we get this. Multiply both sides by h. So that's going to give me h log base 2 of 0.7 equals -4. Okay. But I'm trying to solve for h. So now I'm going to divide both sides by log base 2 of 0.7. So h equals -4 divided by, and I'm going to use the change of base formula, log of 0.7 over log of 2. And again, I'm going to need parentheses around the whole denominator, around the 0.7 and around the 2. So this is very much like when we did a minute or two ago. So I get -4 divided by parentheses log 0.7, close that up, divided by log of 2, close that up, and then close up the whole thing. And I get 7.77, and it said round to 1 decimal place, so that would round up to 7.8 years. We okay with that? All right. Let's take a look at problem number 11 in that same section. We good to go on? Yeah. Yes. Okay. And let's see if I can remember to change to the right screens this time. Okay, it says an isotope of thorium-227Th has a half-life of 18.4 days. How long will it take for 86% of the sample to decompose? Okay, so once again, A equals A sub 0 times 2 to the -t over h power. The half-life, so h is 18.4 days. How long will it take for 86% of the sample to decompose? So time is the unknown. If 86% decomposes, that means that our starting amount is our starting amount, A sub 0 is A sub 0. But the ending amount, if 86% decomposes, how much is left? 14% of A sub 0. So that gives us this information. Okay, we've got our formula. The half-life is 18.4 days. We're supposed to find the time. The original amount we don't know, so it stays the original amount. But the new amount, it loses 86%, so it still has 14% of the original amount. So the final A is 0.14 times A sub 0. We okay with that? So now my equation becomes 0.14 A sub 0 equals A sub 0 times 2 to the -t over 18.4 days. I'm going to divide both sides by A sub 0. 0.14 equals 2 to the -t over 18.4 days. I'm going to change it to a logarithmic equation. Log base 2 of 0.14 equals -t over 18.4. I want to solve for t, so I'm going to multiply both sides by -18.4. So on the left side, I get -18.4 log base 2 of 0.14. On the right side, I get t because the 18.4s and the double negatives go away. So t equals -18.4. I'm going to change this using the change of base formula. into log base 10 of 0.14 over log base 10 of 2. Let's write that a little bit better. Let's try that again. There we go. Okay. So log of 0.14 divided by log of 2. Again, we're going to have parentheses there and there. And let's see, negative 18.4 times the log of 0.14, close that up, divided by the log of 2, close that up, and I get 52.191. Said round to the nearest tenth, the 9 would round up, so we get 52.2 days, because the half-life was in days. Okay, let's see, that's number 11. Now, we've got some other questions here. Chapter review. Number 6. Come on, here we go. Okay. We okay with that problem? Are we good to go on? I'll take that as a yes. Okay, so now we're going to look at chapter review. This is chapter 11 review, and this is number 6. Okay. It says the population of Earth is approximately 6.8. Ah, yes, I remember looking at this one yesterday. So let's take a look at the student's answer here. Okay, can you see the student's answer there? My guess is that that number they came up with, there's nothing wrong with it, but the problem with this situation is, notice how it says the population of the Earth is approximately 6.8 billion. When they give a number that's some digits followed by a word like hundreds, thousands, billions, or whatever, then your answer should likewise be in billions, which is why if you see down here, they've got billion people. Now, the answer they wanted is 9.0 billion people. It said round to 1 decimal place. If you take the answer that the student got, but you write it in billions, it would be 9.0 billions. So they probably did their calculations correctly. It's just that they need to pay a little more attention to how to write it. And I know that's tricky. Having said all that, do you want me to do the problem, or are you okay with it?
Can you do it?
What?
Can you do it?
I will do it. You betcha. Okay. So we're going to use A equals PE to the RT. This is not a half-life formula. It's the beginning amount. So the beginning population is 6.8 billion. The annual rate, so R is 1.133%. And the time is 25 years. Okay, so now again, we're using A equals PE to the RT. So the starting amount is 6.8, it's in billions. The annual growth rate, I'm going to now convert into a non-percent, so that's going to be 0.01133, because you'd move the decimal point over 2 places to the left. So from here, 1, 2, okay? All right, so A equals 6.8 E raised to the 0.01133 times 25, close it up, years, and let's see what that equals. Okay, I'm gonna over here, I'm gonna write in billions because the number 6.8 is in billions. All right, so 6.8 times e to the 0.0113, oops, 33 times 25, close it up. And I'm coming up with 9.026571461. Okay, which is basically what the student had. Theirs went out even further. But if it's in billions, so then this number would be 9.0 in billions. Okay. Does that make sense? Because the problem, if the original number had been written like this, then we would have written the whole thing out like that. But because it's 6.8 billions, we find our answer in billions. Okay, we're going to take a look at number 23 from this student's questions. We good to go on?
Yeah.
All right. So this is also from the chapter review. This is number 23. And let's see what it says here. If $11,600 accumulates interest at an annual rate of 8% compounded continuously, how much will be in the account in 60 years? Okay, we've got two interest formulas. The first one is A equals P times 1 plus R over K to the KT power. And the second one is A equals PE to the RT. Because this is compounded continuously, we're going to use the second formula. And the principal is $11,600. The annual rate of return is 8% or 0.08. And time is 60 years. So, and this is round answer to 2 decimal places. Okay. So again, we're not going to use this formula because the interest is compounded continuously. So we're going to use the A equals PE to the RT. Principal $11,600, interest rate 8% or 0.08 times 60 years. So A equals 11,600 E raised to the 0.08 times 60 power. So 11,600 times e to the 0.08 times 60, close that up, and I get 1409520.843. Now, it said round to 2 decimal places, which would be here. So the 3 would round down. So this is $1,409,520.84. Alrighty.
So how would you do an equation that was compounded semi-annually and compounded quarterly? Because those are the problems I have most trouble with.
Okay.
And I think
So if it was compounded anything other than continuously, we would be using this formula. Okay. Now, annually would be K equals 1. Semi-annually, K would be 2. Quarterly, K would be 4. Monthly, K would be 12. Daily, K would be 365. Does that make sense?
oh, okay, yeah, that makes sense because I'm not sure if we practiced these before, but it was on the review and I didn't know how to do it, and it was multiple choice, so I just guessed and I got it right, but I didn't really know how to do it.
Yeah, we had some of these. If you go back and watch the videos way back, it's been a while because it was like I think it was on the first section we did through 11.3 is when we first introduced this compound interest formula.
Yeah, I must have forgot or something, but thank you
That's okay.
for explaining that.
All right, we good to go on? So
Yep.
Okay, so now let's see here. Okay. 11.7. Number 12. Okay. So this is 11.7, number 12. And this is similar to one that we did earlier today. An isotope of lead has a half-life of 8.4 hours. How many hours ago was that 50% more of the substance? Round your answer to 1 decimal place. All right, so we're going to use the half-life formula. A equals A naught 2 to the negative T over H. And we know that H, the half-life, is 8.4 hours. And time is the unknown. But what about A and A sub 0? Well, the ending amount we know, so A is A, but A sub 0 would be A plus 50% more of it. So it'd be 1.5 of the ending amount. Let me show you what I'm writing here. So again, we're using the half-life formula. We know the half-life. We're trying to find the time. The ending amount is established. It's the beginning amount was 50% more than the ending amount. So the beginning amount was the ending amount, which would be 1A or 100% of A plus 50%, so 1.5A. You okay with that? So we're kind of going backwards there. So let's see. Now our equation becomes A equals 1.5A times 2 to the negative T over 8.4 power. Divide both sides by A. 1 equals 1.5 times 2 to the negative T over 8.4 power. Divide both sides by 1.5. 1 over 1.5 could be written as 10 over 15 or 2/3. Same thing I did earlier when I had 1 over 1.8. I'm going to multiply by 10 over 10 to get rid of the decimal and then reduce it down. Okay. Change that to a logarithmic equation. Log base 2 of 2/3 equals negative T over 8.4. Multiply both sides by negative 8.4. And we get negative 8.4 log base 2 of 2/3 equals T. So T equals negative 8.4. I'm going to use the change of base. Log of 2/3 divided by log of 2. I'm going a little faster here just because it's just like a problem we did, and I've still got a bunch I'm going to try and get through for people. Okay, so negative 8.4 log of 2/3, close that up, divided by log of 2, close that up, and I get 4.91, rounding to the nearest tenth, 4.9 hours. Okay. And now we're going to look at problem number 14. Are we good to go on? I'll take that as a yes. So this is 11.7, number 14. Okay, this says a sum of $4,000 deposited in an account grows to $8,000 in 5 years. Assuming annual compounding, what interest rate is being paid? Assuming annual compounding, so it's not continuous, and annual would be once a year, so K is 1. Okay, so A equals P times 1 plus R over K to the KT power. P is $4,000. A is $8,000. T is 5 years, and we're supposed to find R. All right. So $8,000 equals $4,000 times 1 plus R over 1. Well, don't know what R is, but R over 1 times, oh, I should have put down here that K equals 1, sorry. And then this is what? Raised to the 1 times 5 power. Okay, so I'm going to do a couple of things here. I'm going to divide both sides by $4,000. So I get 2 equals 1 plus R. R over 1 is just R, and 1 times 5 is just 5. So I get that. Okay. Now's where things get a little bit tricky. Because we're not solving for the exponent, we're solving for R, which is inside. So I have something raised to the 5th power. I'm going to take the 5th root of both sides of the equation. So the 5th root of 2 equals 1 plus R. I'll subtract 1 from both sides. So the 5th root of 2 minus 1 equals R. Okay. So the 5th root of 2, do we know how to do that? Remember, your calculator should have a button that's the xth root. Or you could take 2 and raise it to the 1/5 power. Let's do that. So R equals 2 to the 1/5 power minus 1. Do you remember where I'm getting the 1/5 from? The index is the denominator of the exponent. Okay, so 2 raised to the 1 divided by 5 power minus 1. And I'm getting 0.14869. Okay, now that's not a percent yet. It says round your answer to 2 decimal places. Converting it to a percent, it would be 14.869. Rounding it to 2 places would be 14.87%, which is the correct answer. All right. We're now going to go to some chapter review questions. And let's see here. This is number 5. And 11. Yeah. Okay. So this is the chapter review. Chapter 11 review number 5. And let's see here. An account now contains 3640 and has been accumulating interest at 6% compounded continuously. How much was in the account 4 years ago? So we're going backwards in time, okay? But it's compounded continuously, so we're going to use A equals PE to the RT, okay? A is the final amount, and that is $3,640. P is the unknown that we're trying to find. Okay, so P is the unknown. R is 6% or 0.06, and T is 4 years. Okay, so let's look at that information. So we're going to use this formula because it says it's compounded continuously. We know the ending amount, we need to find the starting amount. So $3,640 equals PE to the 0.06 times 4 power. In this case, I'm going to be dividing both sides by e to some power. So I'm going to go ahead and calculate 0.06 times 4. So this is to the 0.24 power. Okay. So now I'm going to divide both sides by e to the 0.24 power. So P equals 3,640 divided by e to the 0.24 power. And on my calculator, 3640 divided by e to the 0.24 power. And I come up with 2863.325, rounding to the nearest cent, or the nearest, or to, yeah, it says to the nearest cent. So this would round up, so we'd get $2,863.33. Okay. And let's see here. We're going to go on to number 11 on the chapter review. How much will $10,100 become if it earns 9% annual interest compounded quarterly for 60 years? So A equals P times 1 plus R over K to the KT power. P is $10,100. R is 9% or 0.09. K is 4 compounded quarterly, and T is 60 years. All right, so now we've got all our information. A equals 10,100 times 1 plus 0.09 over 4 raised to the power of 4 times 60. I'm just going to put that whole thing in the calculator, all as it is. So 10,000 times, so parentheses, 1 plus 0.09 divided by 4, close parentheses, raised to the power, so the little caret, parentheses, 4 times 60, close parentheses, and I come up with, let's see here. Oh, I see that I made a mistake. I put in 10,000 instead of 10,100, so let me fix that. All right. So I get 2106286.173, rounding to the nearest tenth. It would be $2,106,286.17. Okay. Okay, let's see here. That takes us to number 23. So this is still in the chapter review, number 23. If $10,100 accumulates interest, wait a minute. Did we just do that one? I guess, no, we didn't. No, we didn't. That was compounded annually. This is compounded continuously. I thought things just looked familiar. Let's see. Okay. It's different anyway. Sorry. Okay. So we're going to use A equals PE to the RT because it says it's compounded continuously. The beginning amount is $10,100. The annual rate is 8% or 0.08. Time is 60 years. And we want to know the final amount. Okay. So A equals $10,100 times E raised to the 0.08 times 60. I'm going to punch all that straight into the calculator. 10,100 e to the parentheses 0.08 times 60, close the parentheses, and I get, that's supposed to be a dollar sign, 1227255.217. That's going to round up. So let's see. We're going to get $1,227,255.22. Okay. And now we're going to go to number 33. It says, solve the equation, express your answer to 4 decimal places. And it's the natural log of x equals -7.5. Solve the equation, express your answer to 4 decimal places. Well, natural log is the same thing as log base e. So natural log of x is log base e of x equals -7.5. If I take this logarithmic equation and change it into an exponential equation, I get e to the -7.5 equals x. And if I put e to the -7.5 into my calculator, -7.5, okay. I get this, I get 5.530843701 e -4. Now, what does that mean? That means times 10 to the -4 power. So if I got 5.530843701 times 10 to the -4 power, if I wrote that number not in scientific notation, okay, what does 10 to the -4 power do? To change that, you'd move the decimal point to the left 4 places. So 1, 2, 3, 4. So I get 0.000553, etc. It says to 4 places, which would be right there. That's going to round up. So we get that. And I'm guessing the tricky part there was recognizing what that meant. Okay, scientific notation. All right, we got one
I
more.
think you froze again.
Sorry?
Yeah, he froze on my end.
You were frozen.
Am I still frozen?
No.
Nah.
So can you see what I did there, or do I need to repeat something?
No, I got it.
No,
Okay.
yeah, we could see well. Thank you.
Okay,
I have a question.
Yeah.
Did when you punched it into your calculator, did you get the 0.0005, et cetera, or did you get the 5.53084?
I got this thing.
Did you get that?
I got that. Now,
Oh, my calculator gave me the decimal one.
right, and that has to do with the settings on your calculator. There's like an engineering, scientific, there's a,
Oh, yeah.
so that's, yeah, okay.
Okay.
All right, I got one more to do here, and then we're going to be out of time. So let's see here. This is number 38 on the chapter review. It says a wooden statue found in Egypt has a carbon-14 content that is 3/4 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? Okay, so again, we're going to use A equals A naught 2 to the -t over h power. And we know that the half-life is 5,700 years. And time, how old the statue is, that's what we're trying to figure out. It is 3/4 of that that's living. So we don't know the starting amount, that's A sub 0, but the ending amount, A, is 0.75 of the starting amount. It is 3/4 or 75% of the starting amount. So that gives us this information. All right. So 0.75 A sub 0 equals A sub 0 2 to the negative t over 5,700 years. Divide both sides by a sub 0, 0.75 equals 2 to the negative t over 5,700, which it becomes log base 2 of 0.75 equals negative t over 5,700. We're going to multiply both sides by negative 5,700. So we're going to get t equals negative 5,700. I'm going to use change of base, log of 0.75 over log of 2. Okay, and I know I'm hurrying. It's because the next meeting is starting very quickly. Negative 5,700 log 0.75, close it up, divided by log of 2, close it up. And I get t equals 2365.7. It says round to the nearest 100 years, so that would be 2,400 years. Okay? And there we have it. So I'm going to stop the recording and